Let us work out this differentiation question. We have a function, it is a cubic polynomial, and we are asked to find all the stationary points of f of x. Stationary points exist when f prime x is equal to 0, which means the gradient is equal to 0 at this point, at a stationary point. So let's look at part 1. We must find f prime x, which is another way of writing dy dx. So dy dx of 2x cubed is 3 2s are 6, x to the 3 minus 1, which is 2, minus 9x squared, 9 2s are 18, so we have negative 18 x to the 2 minus 1 power, which is to the power 1, minus 24x, dy dx of that is minus 24, and dy dx of 7 is 0. So this is our first differential, 6x squared minus 18x minus 24, and at the stationary points, f prime x must be equal to 0. So we have to solve this equation. We will divide by 6 throughout. So we have x squared minus 3x minus 4 is equal to 0. Then we're going to factorize this quadratic expression here. So we have x squared minus 4x plus x minus 4 is equal to 0. We factorize two terms at a time. X times x is x squared minus 4. And we have minus 1 times, we have plus 1 times x minus 4 is equal to 0. We continue our factorization. This will give x minus 4 multiplied by x plus 1 is equal to 0. This will give x is equal to 4 when x minus 4 is equal to 0, x is equal to 4. And when x plus 1 is equal to 0, x is equal to minus 1. So these are two values of x. And when x is equal to 4, we will substitute that into our f of x expression. So we will have 2 multiplied by 4 to the power 3 multiplied by 4 to the power 3 minus 9 multiplied by 4 to the power 2 minus 24 times 4 plus 7. This will give the value of y when x equals 4. So when x is equal to 4, y is equal to this. We'll work this out now. 4 to the power 3, 64 times 2 is 128, minus 9 times 16, let's do that, 144, minus 24 times 4, which is 96, plus 7. So we will work this out. 128 minus 144 minus 96 plus 7, and that is equals to minus 98. So we have negative 98 here, and when x is equal to minus 1, y will be equal to, and we substitute minus 1 into this expression for f of x. So we have 2 times minus 1 cubed minus 9 times minus 1 squared minus 24 times minus 1 plus 7. Let me work this out. Minus 1 cubed is minus 1. So we have 2 times minus 1 minus 9 times positive 1 minus 1 squared is positive 1 minus 20 plus 24, because the minus 24 times minus 1 is plus 24 plus 7. So we have 2 times negative 1 is minus 2, minus 9 times 1 is minus 9 plus 24 plus 7, which is minus 11 plus 31, which is 20. So y is equal to 20. So our two stationary points are 4 and minus 98 and x equal minus 1, y equal 20. These are our two stationary points. The coordinates of our two stationary points are shown. Now we are asked to determine the nature of each of the stationary points. So for that we'll use d squared y dx squared, or we will use the second differential f double prime x multiply, this is part 2 here, we multiply 6 2s are 12x, and dy dx of minus 18x is minus 18. And when we substitute x equal 4, we get f double prime x, or f double prime of 4 will be 12 times 4 minus 18, which is 12 4s are 48 minus 18, which is 30. Okay, so now we have d squared y dx squared, or f double prime x is more than 0. And because 30 is more than 0, that means that the point 4 minus 98 is a minimum point. It's a minimum point. And let's look at when x is equal to negative 1, what happens? F double prime x is equal to 12 times negative 1 minus 18, which is minus 12 minus 18, which is minus 30. Which happens to be less than 0. So before 30 was more than 0. And that's why the point 4 negative 98 was our minimum point. Now this point negative 1, and I'll write it over here, the point negative 1 and 20 is a maximum point. Maximum point. Since f double prime x is less than 0. So that is our answer. I hope that this was useful to you, and have a good day.